All right, so there two. So I'm gonna go over two issues again with the lab from last week. So basically, I created a new lab section, went to world settings, and then set third-person game mode just because I wanted something set here. Um, Use the third-person character because, and then I set my HUD. Then I set a HUD class. And this is good practice. This is good. Like it doesn't make sense to have done this in the level. Like you can do this in the level blueprint. It doesn't make sense to do that in level blueprint. It should have been done in a HUD class, and that HUD class should be set. So that's what I've done. I've basically built a BP Lab '07 HUD. I've gone in and I've got a new version of the lab document which I don't think I've uploaded yet, but I'll do that after class. So those of you who are having issues with like what's going where and why, the lab document it clears that up. So with the HUD in place, um, basically I've also broken down like the steps, like hey, show the mouse. The next was setting up the main menu widget and the about panel widget, and we add the main menu widget to the viewport right away, whereas the about widget is basically added and removed based on the button presses. This is where things get weird. The way that things were wired previously were too was clever blueprinting, and you were having issues understanding what was going on. So I basically broke it down into basically here's the set, here is the about panel, here's the main menu, here is the main menu which in the about panel, and it's very the names were also I also gave you names that help understand where what variable is where. So I put like again in the HUD there is the about panel widget, the main menu widget, and in parentheses I put in HUD. And normally you wouldn't necessarily put the parentheses that in HUD like on the variable name, but I did so to help you understand where things were. And then I have the about panel in the main menu, and this is in the main menu widget, and then there's the main menu reference in the about panel widget. So this will get uploaded later today. The other thing that went on, and if I go and I press there is the so I did a basically what I did is I brought over rather than using the third person pawn again, I made a copy of the third person pawn and did what I needed to do with it. And in this case, basically, this is this. I'm going to actually turn off the HUD for one moment, just so that we can isolate that. So basically, they said, hey, put a change the first person blueprint, your pawn class, and give it a widget that is attached to the class. So if we go BP collection pawn, we go to the viewport, we can see that there is, and I'm in the wrong, I'm in the collection game. Hold on. Here's Lab 7. So here is the pawn. And this is what they're talking about, is that we've added a widget component. All right. To do this correctly, so the way that I've got this right now, I'm going to show off some. This is so basically say, hey, put this widget on it and do what you need to do. Let's go back to the pawn. So one of the things that I did with the panel, there's a material here, and you'll see there's a bunch of different 3D widget. Uh, no, get out of the way. I think, which one was it? I believe it is 3D widget pass-through mask one-sided was the original material here. And if we go and I'm going to save compile, save, and we'll press play, you can see that the panel has basically a shadow on it. And I didn't want that. So I basically went through the material here and picked what was, I think, what was the, I picked basically 3D pass through, and we close save everything. You can see that the panel doesn't have a shadow in this case. So it's a material change to do that first of all. The second is that as you can see that the panel right now is basically attached to my character. It's sitting on my head appropriately, and the panel is facing the camera. And that's not what you would normally get. Basically, if we go back to the pawn, what I've done, you can see right here that it is on top of my head, and as my character moves, the panel is moving as well. And that's because the socket I've said I basically have created what's called I've got a hat socket here. I'm going to remove that for one moment. And so what you would normally have done in the lab. Let me turn this to face the player. Is you probably have done something like compile that. We'll go back, and so now we've got that. It's still part of the player, but it's facing the front of the player, and you can see that it's not facing the camera all the time. If we go out, oh well, it is facing the camera. Hold on. Let me go to the event graph just quickly, and yeah, let me break this for one moment. There we go. So you can see it's not facing the camera. It's fixed, and that's this is again this is intended. This is the behavior. I mean, this is if you were building a monitor, and on that monitor there were HUD elements you could interact with. That's what this widget. That's the idea behind this widget piece. Again, I'm using I believe is it return or is it tab? Yeah, I've set up the tab key to basically toggle the visibility. All right, let me go back. So one of the things that I've done, let's go to the character mesh, and we know that it is using this SKM character single. And if you go use the browse, you can click this folder with a magnifying glass. It will bring you to the model, the actual asset. And I've actually gone into the asset in this case, and there's all these different bones. I eventually went through and I found the head, and I actually searched for the head bone. Trying to find it. There's a lot of bones. Here we go. All right, so what I did is I clicked on the head, and I actually then added a socket. So what's a socket in Unreal? So this is something you can do to a mesh, particularly a skeletal mesh. Is that you can then add what are called sockets. And for those of you who are using Unity, think of them as basically a empty game object. It's a point of reference on the mesh. And for our purposes, I added a socket called the hat socket, and I actually moved it up to sit right here. Now, if I was trying to be more like a hat, it'd be like that. But I'm just going to have it sit up here effectively for our purposes. Why did I call it the hat socket? Because it's on top of the head. So I added a socket to the mesh, saved the mesh, closed it, and then I went back to the status panel. Again, I parented to the mesh itself, and I went through and there's a parent socket, and I was able to go through and select a different parent socket. And I know I could have gone to the head bone, but I went, again, I had that hat socket, so I selected the socket. So you can choose a socket or a bone. You'll see sockets used I have a point on my mesh to place a model, like a weapon. I have a spot on my mesh that I will want to use in order to basically do an effect from. So what I've done is I've parented the panel to the mesh. If we go back to the viewport here, I need to put this back at 000. You can see, and I need to set the rotation back to 000 right here. So I started it off with no rotation. So I'll do that and I'll compile. The other thing that I did is I set a world rotation to the, so basically there's the status panel. And I took the follow camera. I basically got their world locations and made a rotation, a look location. So basically, basically like where the start, what were the object in question, and then the camera in question is basically how this node is works. And it returns back a rotator, which is the rotation. I set the target, and I basically plug that in. So every tick I'm figuring out where my panel is in the world, because it is a object in the world. This when we do the panel this way, it is now an object in the world. Like the skeletal mesh is an object in the world. The camera is an object in the world. So basically, I'm just every frame, I'm basically getting the vector between the status panel and the follow camera to generate a vector so that I can then basically tell this panel to face the camera directly every frame. And I'm going to compile this. So I'm going to bring this in. Let me see. I'm just going to leave this here for one. Let me make this a little bit bigger. I'll leave this here in frame for a sec. So I've compiled to go back in the world. I'll press play. You can see that now that panel is going to face the camera regardless where the camera, whether I'm facing my character, behind the character, on the side. There is one condition where this fails, and it's basically up here. That this from a straight from above perspective, um, that vector look at fails, and that's gimbal lock. Because we're dealing with vectors, we're then generating the rotation, and there's really not much you can do about that. The only way to keep that from happening is not keeping the camera straight down on top of the character. That's the only reason why this is happening, and that's the polished piece, just like a small angle, just off by a little bit, and it fixes that issue. So that's just one thing to be aware about. And that's you write a little more code and it's polish. That's pretty much like again the issue with the second assignment was that it told you to make a panel, but didn't tell you to do anything with the panel whatsoever. Like for my purposes, I put the word status on there and then a health bar, or could be eventually. It's a progress bar, which you could use for a health bar effectively. Um, and I put a background on because I could, but and I'm using the tab to hide and show it. But again, the lab assignment didn't tell you what to put in the widget, which is like, okay. Again, there was no like they wanted you to put like a health bar in there or indication. It wasn't very clear what should go there. So basically, I've just basically said, here's status. Here's a something that could be looks like a health bar for our purposes. So those are the only two things. Those are two things. Again, if we go back to our collection game, one of the things is I brought in a new enum so that we had the start game, the playing session, and the end game session. Yeah, what's up? Let's go back. So I parented. So first I made the parented the widget to the mesh in the components, the hierarchy, this hierarchy area. And then, as one of the things is then under sockets, I told it its parent socket really should be the hat socket. So that's why it's flat. Because I mean that's the natural rotation. Like there was no rotation on the object. And I didn't worry about rotation because I was going to go back because my in the event graph I've got the on every tick I'm setting its rotation to face the camera effectively. Yeah, it's flat because I didn't set a rotation. I could have, and you remember when I unparented, I put it out and I set the rotation. And that was like originally how when I first played with the widget, that's how I set it up. I set up in front of us. I think the assignment wants you to do something like that as well. It says, hey, put it out in front of you. It's floating out in the world, which is like okay, useful but not there's useful to things with that. Yeah, I mean like if you were in a first person view, that would be more useful. That's like in a VR setting, that would be like here is this bubble around me of things. Not Beat Saber because Beat Saber is third person. The, I'm not sure where you're going with Beat Saber. Yeah, like so. All right. And that brings up like a concept here is that there are there's a term it's called non-genetic and genetic, and I'm pronouncing it wrong. Basically, is something is does this affect and this goes for sound. Um, sound is the big one for this, but also um, the HUD. Like, is it part of the world or is it not part? Basically, the word means is it part of the world or not part of the world? The non-version not being part of the world. So in so things that are genetic, like in excuse me, Dead Space, your spine is a meter. So basically, the developers realized that hey, players going to see the back of this character all the time, and so the spine of your character it has a glowing meter, and I forget what exactly it is. Is it your health bar? Okay, so your health bar is in your spine, basically. Um, in the terms of like Navi would be another degenic element in the game. It's a help aid. She's kind of like part of the HUD essentially, but in the world. So like again, this is I bring up Helldivers plays this up where if you are using your map when you're using a trying to type in a stratagem, your player goes in a mode where he's like doing something with their arm. Whereas like I'm bringing up a map, or in the case of or I'm typing into the stratagem into my the arrow keys of the stratagem into my arm to then generate the ball to throw wherever it's going to go. But that's the idea of bringing the idea of that actually typing that in. It's not just a piece on the HUD. It's bringing that more into focus of that your character's actually doing something on top of actually doing something. Same thing with when you go to the extraction, we call it an extraction. Basically, your character is interacting with a terminal. So that's something just to be aware about. All right, let's go back and let's take a look at the. So this week we've got some AI and fun stuff. Okay. Oh, this is the assignment. Hold on. Let's get to the module. So you've got four pieces of assignments and two lecture slides. So let's get to it. Let's go through these slides. Do yourself a favor, and you probably want to make a lab 8. So if we go back in here, do yourself a favor in your content draw, go to content. Let's make a new folder. Call it lab 08. And then do yourself a favor, and I'm going to close these. I'm going to file. I'm actually going to say, yeah, I'm going to just make a new level. And it will be basic. And I'll file save current level as. Go to the lab 8 folder and just call it lab 08. So make a new file. For game override, I'm basically going to just use the third person game mode for right now. We will probably might copy the new make a new pawn in here. Um, but we'll worry about it in a moment. That's not what I want. Okay. Why is there we go zoom. All right. So more blueprints and actions. Uh, this is going over stuff you know already. Transformed world coordinates, relative, IK local versus world. Yeah, this is you've known. So this is stuff you know already. So transform every actor has a transform. Details, location, rotation, scale. World coordinates, and we've talked again. Basically, so world coordinates is basically where something is in the world itself, and it is relative. It is there is its orientation point. So, like for the player, we want that at the feet. And a lot of things we've said, hey, we're going to set this up at the bottom of the object. So when we place it down, we're going to place it on the floor. Doesn't always have to be like if we're talking about a wall clock, that orientation could be on the back of the clock. So it's more of where are we placing that on the wall type scenario. Again, location, get actor, get set actor location, get world offset. Uses a delta value to modify the current position of the actor. So this is if you wanted to move the object. Relative transform. So again, we've got the base and the power pill, and what they're saying is the power pill is basically like it's basically hovering above the base, and so like the power base is the root object here. And the power pill is basically something that's hovering on top of the base object. Now, the base could be like 55, 55, 0 somewhere in the world. So it doesn't matter where, it could be somewhere in the world. But the power pill right now, basically the location of the power pill right now is that they're saying here it's 0070. So that's relative to where the base is in the world. Again, this is relative. Basically, we would refer to this as its local position as opposed to its world position. The base itself doesn't have a local because it's the root object. So when we say its local position, we're just going to get back the world position in that case. That's usually what happens. When you're the root of something and you ask for its local position, it just returns back the world position. Um, Now, this is obviously has been transformed, and the pill is its own shaped. So a lot of times what you'll see is that in order to make sure that so if I actually built the position of the power pill, it would be transformed by the position by I'm sorry the scale of the power pill. It'd be transformed by the scale of this object right here as well. In order to do that, basically we use you'll see that we have a default scene, or we have a scene somewhere at the root in order to basically where that is basically being the container to hold all the other objects. So we're not dealing with this transform having been applied to that one and then trying to do the math. It's just basically just rather than having this object being the root, we basically have the default scene be the root, and then we attach all the other objects underneath it and scale them as we see fit. And here's the relative transform functions. Locations, world location, points and vectors. Again, we've looked at this before. Again, a point in space is basically a vector 3. You've done vector addition already. I think you've vector subtraction. You've looked at the length of a vector. Again, we've done the a minus b, and we've asked, hey, are we close to this location? We've also said a minus b and be like, oh, what's the direction? Normalize it, and that would be our direction. So normalizing vectors, scaling, dot product. Again, this is something very like relation between two vectors, whether they're perpendicular or perpendicular or parallel. Excuse me. That ended up being a mouthful at the moment. So if it's a dot product of one, they are parallel in the same direction. If it's a dot product of -1, they are uh, perpendicular, but in opposite directions. So looking at a vector that you want to like, hey, is this vector? Am I looking at the camera? Look at vectors. Basically, the closer you get to -1, the closer you are looking at something. They'd probably do a dot is the dot product above like zero point 0.8 or zero point 0.9, as opposed to saying is it -1, because that's hard to get that perfect -1. So they'll be like, hey, is the dot product above? Well, actually, this could be below zero point 0.8, negative zero point 0.8, negative zero point 0.9, getting towards -1. Get forward actor. Again, this is just basically get actor the forward vector. So we've gone over these already. Let's see. Let's go over this. So, come on. If Canvas would like to load this. Canvas would like to load this file. Let's go over while we wait for that. So, Lex, this is lecture 10. Paracon VT rotation. What are we doing here? Okay, so basically what's going on, and this is a great example. So we'll just this is a blueprint class. It's going to be an actor, and this is going to be a BP. I'm going to call it rotating. And so, oops, rotating. Oh, here it is. So went into the content draw. We went to the starter content, and we went to shapes. Where are the shapes? Here we go. So I'm gonna put they use the round pyramid. I'm using the quad one for our purposes, and then they added a sphere. And I'm going to basically I'm going to I'll make that the root. I'll make the sphere half its size, 100. It's just how it's looking funny, and I'll do 150. And what we did with what they said is they added a should be a rotating movement component. Yeah, that's what I should have been using earlier. And they want to just basically set a rotation rate. They're doing 180. And so when we compile and we go back into the world and we drop, let's go back to lab 8 now. So if we drop this into the world, we press play, you can see that this the so I use the square base, so we can see that that object is rotating, and by the virtue of being parented, the sphere is rotating as well. And that's I mean that's basically if we want to go faster, that is the rotation rate. So I can crank this up to 360. So right now that's doing 180 degrees. So it's 2 seconds to do 2 seconds to do one rotation. Here it's going to be 1 second for, I can jump this up. This is basically a half a second for each rotation. So that's kind of what they're trying to do. They're showing you how, hey, blueprints in action. You see the next one, exercise two. Vector BP, open BP. What are they adding? What are they doing here? I think I've had you do this already. Yeah, you did this. You did the path runner already. Yeah. Let me hold on. I'm actually gonna change the assignment. Yeah. This. Hold on. Yeah. You've done this already. Hold on. Let me edit this. You've done that. Basically, it's basically trying to generate a random location in the world, and it has the object move there. When it gets there, it picks another random location. You did a path runner already. That's pretty much the same thing. So I'm just going to ignore. You don't need to do that. This is. I'm not even sure if this is worth. This is about using the rotator object. So ideally, what I should have done, if we go back into, we go back to the collection game. We go to items. What I wanted to do was I wanted the orb to rotate around. I should have added the rotating movement component here. Jump back into the collection game map. Yeah, save everything. And then, so again, let's press play. And there we go. We jump in. And you can see that. That's kind of what I wanted them to look like ultimately. The other thing I probably should do is add a little bit of hovering movement on it, but it's another question. That model, if I wanted to do that, I probably I don't know, maybe I would play with the roots. Um, maybe I probably would have added another scene. And these two I could parent. I wouldn't be able to move the scene because it is inherited and can't be reordered. So I've ignored the model here. So this is going to be the scene root. Actually, this would be the model. So I can play with this root here. Again, it's basically a empty object. The whole thing's for our purposes, it has a transform and gives us that, so we can then I could then play with this later on. But we'll leave this alone at this point. Let's jump back. Let's look at your next piece. Yeah, this is the one I threw out. As you spawn an emitter, that's not a big deal. Yeah, this is just basically having you go in and basically adding spawning an emitter. You know what? I'm gonna take this out as well. This is like, you did the explosion. That's just basically like, hey, when this we haven't been playing with the first person. We haven't been playing with that template, and it's just like, oh wow, the projectile that we shoot now spawns an emitter of fire. Like, wow, big deal. Yeah, that's not really anything spectacular. Um, yeah. So what they're doing here. So this is actually important. Background delete and functions. Yeah. Okay. So let's go through the slides now that they're actually loaded. Hooray. Come on. There we go. All right. So this is add child actor component. So basically we can add components on the fly. Like that you can build components, add components to an actor. Um, they're gonna show you the tags, and I'm gonna tell you don't like. I don't like the tag system. Tag system is probably better in Unreal than it is with Unity. To be quite honest. Um, Again, in Unity, the issue is that your game object consists of other game objects, whereas in Unreal, it is a single class with component. It's more unified in Unreal, so the tag system works a little bit better. But I can tell you, like, no one like really like in a production setting, the tag is you are using it because someone has determined that you are going to use it, and it's not necessarily something that is used out of the box per se. Again, I'd rather you ask for a particular class type as opposed to use the tag system. To be quite honest. So map range clamped. What are we looking at here? I'm not really sure what this is. Oh, okay. So this is basically. I don't know why you wouldn't. It's doing current arrow and max ammo. I'm not sure why you would use this node per se. Um, like here is the current ammo and in range A or in range B, and out range A and B. I'm not sure why you wouldn't be using a clamp between current ammo 0 and max ammo. Not really sure what the purpose of these other values are really. Why I'm not sure why these. Is it return your percentage? Oh, okay. It's okay. I see what's going on. It's basically giving you a percentage. So based on max ammo, current ammo, and 0, it's giving you a value between 0 and 100, which is the percentage that it's pushing out. So I can see. So this is what it's doing right here. Actor has tag. So basically, we could give tags to items. Here is you can ask if the actor has a tag. If actor has tag special item, do this. Apply damage. So basically, there is the apply damage. So basically, what is the actor that is taking damage? What is the value of the damage? Event in scale. What is the event? We'll talk about event in one moment. The actor of the actor who is causing the damage. And the damage type class. So what type of damage is it? Then you get out here the damage type, damage type, who caused it, and then what is the actor that caused the damage. A lot of this is information here. I mean, the big one is damage. Damage type and all these, again, you can use damage type to figure out, yeah, this damage applies this to the character as well. So the idea here is that you do damage, but there is other properties of damage that you can that there's properties like, hey, I am a fire type damage, like the character on fire. Damage type class again, and then the other thing is damage causer. So that's more for when we get into gameplay, like who caused the damage. You'd ask who is the owner of this character, like who spawned this object, who is control of that object, so that you can then later on give basically give that character credit for the kill essentially, or the damage that they've done. Yeah, kill feeds. That's eventually like later on when you build a kill feed, basically it'd be like this character was killed by this character using this weapon, or this character was killed by this character but because they were lit on fire, and then like the initial hit didn't kill them, but they were then lit on fire and that fire then killed them. Then it would be player A killed player B by burning them to death. Or in the case of like Half-Life Deathmatch, there would be the player on like flaming arms, I'm on fire emoji. Or in another example from Half-Life 2 Deathmatch is when you're killed with with a physical object. And in the Half-Life 2 Deathmatch, the emoji of you being killed by a physical object is a person basically being hit and being hit by a toilet essentially. So for those who do play have played Half-Life Deathmatch, it's not the toilet to throw at people. It's the radiators, like wall radiators, old school wall radiators. Those are the ones you want to pick up and throw at people because they've got mass, and they will kill other players pretty effectively. So again, here is event any damage, and then it's basically going on and it's just taking the health and subtracting it, and sending it back. And then obviously there should be more here about what should you do after you've taken the damage. Get overlapping actors because list of actors are overlapping the current actor. So this is more so like so rather than using um, so there's the something has entered the trigger, kind of begin overlap component, and overlap. As opposed to that, we are they using here's the event timer damage. So basically every second this would be every second basically they're saying every time this gets ticked. So let's say it's a timer of 1 second. So every second this ticks off, it asks get the overlapping actors and what is the collision area, and it goes through and applies 10 damage for each of them. So if you're in this zone, every second it ticks off, and it does applies damage. And again, I'm using a second. It could be half a second. It could be every 3 seconds. Yeah. So examples of what would use something like this: a slime volume or a lava volume, that you've set up customly into the map. Um, because again, the collision could be moving around. That's why again there are volumes like slime volumes, water volumes, lava volumes that particularly slime and lava can do damage to you. There may not be. I'm thinking on Unreal Tournament. There may not be. Let's actually just jump into we're volumes. So there isn't lava. So they don't have lava and slime volumes anymore, but they do have a pain causing volume, which so they've made a generic version of the volume. Physics volume, actor physics. So the water volume would be a physics volume. So the physics of in this volume would have changed. So so again, if you want to play with physics in a particular area, then a physics volume is what you'd want. So if you were making a pool, the physics volume is what you'd be playing with. And again, there's all sorts of different volumes in here to do different things. So um, definitely go back and play because that's more of level design than it is what we're doing in terms of programming right now. So let's get back to slides. So this is getting the overlapping volume. Add child component. What is the basically here spawn weapon? They're adding the weapon component. Here's the weapon transform. Spawn emitter attached. So this is basically we're attaching emitter to an object. So here's an event hit. Attached here. Again, this is the fire emitter. I think the big thing is that we're not setting up. We're not hitting the location is not being set. That's odd that we're not setting the location. Here's the thing that you're gonna use this week is AI move to. AI knows to move a pawn. The destination could be a node or another actor. Level must have a nav mesh bound volume to find an area the AI can move to. Um, so let's jump back to what they're talking about there. Let's go to Lab 08. Jump in here. And we're going to, what they're looking for is it, here you go, nav mesh bounds volume. And so here we go. Um, the thing about the nav mesh bounds volume that I found is that you want it in the floor, just below the floor. You want the surface clearly in the volume. So here is the nav mesh. I'm going to go to its details. And I'm going to set this at 0, 0. I'm going to leave that at 50 for right now. And I'm going to make this like 20 by 20. So I'm going to generate an area like this. I'm going to make this, I'll make this 4 high. I can bring this up, but basically I want this below the floor. And that's so that and I'm going to move this outside of the volume. And so again, the reason why I'm doing that is I want to make sure that this surface in here is clearly inside the volume to be inside the volume. I've had a couple times where I've clicked on the nav mesh box and I've put it on the floor like this, and the navigation inside didn't count the floor as part of the navigation. It was outside. It considered it outside of the box. So for our purposes, we're going to keep it inside the box. So the goal basically, ultimately, again, is there is a AI move to function. It's basically what is the pawn, where is it going? Let's take a look at here is on movement result. We can do stuff up here. We can do a switch off of that. Go to next point. There's a pawn it's itself. Next point is where we want to go. Accepted radius. How close are we going? Can we be? Basically, it's how close do we want to be in order to be within considered being at where we want to go? Let's go jump back and let's take a look at the lab document one more time. Um, so in this case, so what they're saying in our example, we are going to let's go to the third person template. And we're going to take a copy of that and make a copy in there. I am gonna, and I'm gonna rename this BP AI as it's, and then I'm gonna go back to the third person template one more time. I'm going to copy it one more time. copy there. And then this is going to be, I'm going to rename this BP Lab 08 pawn. And I'm going to go to my world settings and I'm going to set the 08 pawn, the Lab 08 pawn for our purposes. So here is our starting pawn. All right, and then I'm going to put into the BPAI, I'm going to put that into the world. And I'm actually going to go in. So what they want, let me see, let's go to the pawn. Where is it? Here it is. Let me see. Is this in camera move follow camera? I believe I can get rid of these. Yep. Don't need the arrow component. Uh, don't need it, but it's inherited from the character. So so basically the first thing is I took out the camera because that was actually added in the third person template. And I actually can go in and I can delete everything in the event graph. And I'll compile. We'll press play, and then there is my other. So let's go to the BPA. Let's just so we have a point of reference. Let's go to the mesh. Let's go to its materials. And I believe it's the second one that I want to play around with. Um, we'll just use. There we go. So I'll use text pulse for the second one, and then the tactile hex tile. Just so, and I'm gonna. So basically, we've got a different material on this on the AI to play with. In fact, I'm gonna go back and I'm gonna change this to pulse, and I'll put this one back to just tile. There we go. That looks a little bit better. You got the pulse across the face. That's gonna look cool. All right, so we'll save that. All right, the goal basically. So let's take a look at the. They are basically they're creating. Move the player. Okay, so what they're doing in is they're creating. Let's go to the event graph. Let's get some space now. They're creating an event. Add event for mesh. No, not for the mesh. We'll make sure it's for the. So we'll add an event, new custom event, and this is going to be move to player. And what we're going to do is essentially, it's the AI move to. All right, the pawn that we're dealing with, this is going to be reference to itself. So this is this actor. The target actor is we're going to go to the get the player controller. This is going to be slightly different. I'm going to get the player controller. I'm going to ask for its controlled. Sorry, possessed. Where is? Here we go. Get controlled pawn. I'm going to plug that in. That's pretty much stop on overlap. Yeah, we'll stop on overlap. Accepted radius is going to be 5. I'm actually going to set this to be. I'm going to do this 20 as opposed to 5. So it's a little bit. We got some room. And then basically on success, what they're doing is they're going to do a delay. So how long do they delay? And then basically after we've got success, where it's going to go off and it's going to call move to player. And then it's just basically a begin play event where they basically are calling move to player. And again, I'm actually going to go in right here. I'm actually going to do on success. I'm going to do a play a sound at location. I'm just going to grab get actor. Not an array. I want. There we go. Now get actor location. There we go. And then the dialogue. Oh, this is play dialogue. I want play sound at location. And we are going to do. I'm just going to use the compile failed sound for the sake of argument right now. And you may not have access to that. Don't worry. Just you can go find. Again, this is extra credit right here. But we can go press play. Make sure we save everything, and we'll press play, and you can see that they are now running after us. And I don't have the sound on. Oh, come on, Windows. There we go. Let's try this again. And it can't find me right now. It's because I went outside of the bounds. And that broke it for some reason. That's interesting. Oh, we'll stop. And that is, I need to play with. I need to play with this a little bit. Probably put this after the delay. That's probably my best bet. Maybe what after the delay. Yeah, again, it's the end. We can play with this a little bit in order to play with that. But this is essentially what our lecture is going to look like. This is what we're doing is we're going to go in and create an AI agent that's going to move around. That's pretty much the basics of what we're doing right now. Just trying to see nothing there. Okay. Just making sure there's no questions in chat. Um, Again, the two big things about the AI needs, again, we need to give it a destination. And again, we could have recreated our path runner using this the third person character. Could use the AI move to different points, and destinations would have been funneled in through path points that we built. So if you want to make an AI that does like has again runs a path, that's one way to do it. And that's basically if you really want to go all out on this assignment, build a guard. All right, guard has this area where the guard can move around. Give guard a way to like sense things, like hey, one of the things that we could in theory do with the BPAI was go to this viewport. We could give it another give it a box collision. We'll put this, and again, we'll make this 50-50-50 to make our lives easier with the math here. Let's say this is like 5 units out. We could give it 3 units wide, and we'll just say 2 for the sake of argument. So if you cross inside this box right here, so again, let's think about let's go to the content drawer. Let's make a new, and this is the guard enum. So let's think about Metal Gear Solid. All right, the guard basically has basically 3 states. It's in the normal patrol state. Hold on. It has an alert state, and then there's the active, the combat state. So again, player is hidden. Guards are not alert. Player is hidden. Guards are in alert. Had seen player or heard sound. And finally, the player is seen. Guards are chasing. May shoot at player if in range. All right. So your question. I just showed you the visibility. No. Um, so hide and shadow mechanic, it basically is player. Basically, there is there's the idea of the light level. So literally, there are places that basically, um, let's take Thief the Dark Project. The Thief the Dark Project has basically knows the light level wherever you're standing in the level, and based on like if you're in shadows, it knows that's there's like let's just say full light, fully lit is at 1, and fully in shadows at 0, and there's like you can be in sort of in shadows. It has a gem, like again, and it uses a gem as part of its mechanic to tell you whether you're in the light or you're in darkness. And based on how far you are from characters, based on what level of light you are in, it plugs into a mechanic and a logarithm that says the guard can see you. There are lots of places, and particularly in Dark Shadows and Thief the Dark Project, a guard can continue on its patrol, walk right by you, and not notice you. And that's just the mechanic of that mechanic. But for our purposes right now, we are basically saying, hey, if you are in this box, you can be seen. Now, there's more we can do that. If it's more like, hey, are you in this box, and does the character have basically a line of sight from you to them? And that's a raycast. Basically, it's a raycast you would do. So if you want to go all out for this assignment, build a guard. Give them, you've done the path runner, so give them a path to walk around. We can go and give the variables. This is, this would be current path point. This would be of type actor. I'm going to. The next one would be, and this. Let's see. This is path points. That's visible, and this is going to be an array. Why is it acting funny? Path point index. This is going to be an integer. No, it's not visible, and this would be single, not an array. So again, here is the path mechanic right here. So again, you'd have the current path point. The other thing I'd probably put in here as a variable is not an integer but a float. Within range. I'm just going to compile that, and I'm going to say that this is going to be 25. I'm going to compile. Actually, go back to the event graph now. So rather than having the acceptance radius, I'm going to just use the within and plug that in. We'll save everything, and we'll press play. Again, right now it's chasing me because so that's how it's set up. And again, we could use, again, like we talked about the overlapping actors. Again, there's the box. So the target is the box. Uh, Again, this is going to be our BP Lab 08 pawn. So on begin playing again, we've got move to player, but we could set up a timer instead, and based on the timer, basically like call the overlapping actors. Again, here is we can get length. And if that's greater than the 0, then we could call move to player. Again, we would want to let's create a new event. Add custom event. This would be the vision tick. I'll put it over here. So we're asking every vision tick essentially here, like basically is if we see if the player's in the overlapping area, move to the player. Why would we do something like this? Let's go back to the lab. Where is the AI? Here it is. So let's again we could I'm just gonna use some boxes. That's not what I want. Outlier. Hold on, content. Content. Audio texture. So here's a wall. Details. Negative 1,000. 100. Negative 1,000. 700. Rotate it 90 degrees. So So here we go. We've got a nice little setup right here. We again, I don't have it. I don't have it set up to be ticking. But again, here is we could set up a small maze to deal with. So a lot of extra credit in this. Again, there is the what is required of the assignment, and there's lots of extra credit to go for. So if you got some points taken off someplace, here to go. Any questions for me? Any questions? Yeah, and that's basically we go back into over here. Like that would be, hey, play a sound. This would be a node right here to play the sound. Let me make this bigger so we can see that better. So like we would play the sound right here. Like here I'm playing the sound here. Again, I don't have any sound effects to use, so I should have something like, hey, stop thief or something in that regards. Or maybe you have basically there's a sound effect that you or a sound cue that you set up for this particular character. Yep, what's up? Yeah, pretty much. I deleted the camera, and the camera boom got removed from because that was added to the third person. So basically, we're stripped down to basically the mesh as a third person character. I really deleted everything out of the event graph, and I deleted the camera because we don't need the camera anymore. Oh, the mesh has a animation blueprint on it. Yep. Yeah. If we look at what the question is, how does it know how to use the walk? Um, it has this animation. So the animation mode, use animation blueprint, and animation class Quinn APB Quinn C. And there's a couple more things inside there as well. But that's basically how it knows that's been set up for you already. No. Yeah. That's a artist feature. Or I mean, at some point, if you want to dig in and you'll eventually dig into it. But for our purposes, we're just using what's the template for us right now. Any other questions? All right, I'm going to stop the recording right now.